My name is Duncan Walker and I'm a Principal Software Engineer at the BBC, and I'm going to talk to you for about half an hour on the things that we do to keep the build green. But before I start, I'm just going to ask a couple of questions just to get a feel for where everybody is sort of in the room. So can you put your hand up if you use a continuous integration server? I'm expecting this to be almost everyone. Okay, but keep your hand up, because I'm going to ask a couple more questions and we'll see how far we get. So do you also have good test coverage? And by good, I mean good enough that you're willing to let things go all the way through to live. You're just going to deploy all the way through. Do you trust that enough to do multiple live deploys per day? Okay, bit fewer people, but still some people holding out. And then the last one is just a test of honesty. And is your build always green?
Does yellow count?
Okay. I don't even know what yellow is, but yes, we'll take that. And one last one. Is there anyone in the room who works for Google? No. Good. Okay, I can say whatever I want. When I was thinking about this, I was thinking about, okay, why are we doing continuous integration? What is it that it actually gives us? And it gives us a couple of things. The first one, the most obvious one, is it's a bit of automation. It just saves us some time. It does things, it reduces the risk of doing some manual handling and stuff. But also, and perhaps more arguably more importantly, it gives us a signal. It gives us a signal about the health of the app. So if it's green, it's telling us, okay, yeah, you're doing well. And if it's red, it's giving you a signal that, okay, maybe you need to do something about it. But then even within those red builds, when your pipeline fails, even within that, there's a couple of different ways that might happen. It might be because something is genuinely wrong. You've introduced a regression, but also it might be something else, a flaky test or a flaky build step. And actually, I'm going to talk about those as well, because they're maybe even more important than the failing test, because when you've got noise, you basically don't have any signal at all. So, okay, why when you're not Google? Often when I've read things about continuous integration and builds and why it's important to keep it green, it's often from a very sort of abstract level, and it's sort of saying, oh, well, this is the sort of thing you should be doing. But it's very rarely in a very sort of practical, pragmatic sort of view. So I'm going to try and talk from a very pragmatic view of what have we been doing at the BBC on my team to try and keep our build green. And so you're going to hear some successes, but also some total failures. And yeah, so I guess the best place to start the story is a couple of years ago when I joined my current team at the BBC. I just joined from another team that maybe wasn't quite as good as this team, and I thought I was in paradise. They had this amazing build pipeline, everything was always green, things were going through really fast, and we were delivering software and customers were happy and everything was great. And that went on for maybe a week, maybe two. And then we had this retrospective meeting, where someone mentioned, oh, isn't it annoying when the build fails? And then another person, and then another person. And slowly we realized that we'd developed a condition. We had a condition of a flaky build. And it was not just an irritation anymore. It was suddenly a real blocker. We couldn't deliver features because people were constantly having to sort of almost manually crank this thing that's supposed to be helping us and pushing builds through. And of course, it probably wasn't a sudden thing. It wasn't like that. It was probably that it had been developing over a really long period of time, and it had just gotten to breaking point, and we just couldn't deal with it anymore. So we had to do something about it. Just to give you a bit of context, this is the sort of thing we had at the time. So this is our Slack channel, #CIBuild, that just shows all of the builds that go through on a given day. And you can see there'd be a few green ones, but then the important one, the signal, is that bit at the bottom, a failing build. And I'll zoom in on that and talk about it a bit more. So this is what it looks like when a build fails, and we get sent a message. And at the time, I've sort of blanked out the name because I didn't really want to put that person's name in big letters on the front. But actually that's part of the story, because at the time we didn't have even the name on there, because we didn't want to have a sort of blame culture of in big lights with a channel with dozens of people in, you have broken the build, Ben. It was Ben. So instead we didn't have a name on, and pretty soon we realised that that is just not tenable. You need to put the name on there. So we just made a little change, just put the name of the person who committed or triggered the build on there. And that sort of cleared up some of the builds where it was something had broken and no one had noticed, or they hadn't picked up on it quickly enough. And another thing we did was to try and make sure that we have a really active discussion on there, so the moment something happens, everyone jumps on it and you can see that there's a few replies on there. And that made a big difference. And then the final thing is my favourite thing, which you might not be able to see, but there's a tiny little, I'll zoom in on that, tiny little eyes emoji like that, which my favourite thing about this is that it required no code and no work and no effort. It was just a convention that just developed over time. And I don't know who was the first person to do it, but just show, very simply, I've seen this, I'm on it, I'm doing something about it. And that made a really, really big difference, because it's so much quicker for me to be able to scan through a list and just see, okay, these ones are red, but someone's on it, and they're going to work on it until it's fixed. So that made a really big difference. And it made... so that meant that we'd picked up on all of the obvious ones. These are like the really low-hanging fruit of the build is broken and no one's doing anything about it. And it just meant that we just stopped having that. Our time to getting back to green got much better. So that picked off the low-hanging fruit, but that wasn't enough. We still had a sort of flaky build. But luckily for us at the time, Google were doing a load of research. That's probably not what their office looks like, but that's research. They were doing a load of research on their own flaky build because they had a similar problem. And they were focusing, they were looking at builds, but they were also focusing particularly on flaky tests. So their definition of a flaky test would be one that fails once or more within a given week, which is interesting because it's a time-based thing, so that tells you something about what they define as flaky. And they did a bit of research on this, and they tried to work out what is it that makes these tests, or they could also be build steps, flaky. And they tried to sort of analyze it from a load of different angles. They sort of checked, or is it to do with the technology that we're using? Is it different products? Is it how we're writing the tests? What is it? And the one thing that they found, maybe isn't surprising, is that the more code you're testing and the more code you're executing more generally, the more flaky it's going to be. And that might not be surprising in itself, but the thing that was a bit more surprising to me is the fact that that is the only strong correlation. So there's a link to the report there, but basically they say they found a weak correlation with some of the tools that they were using, but they thought that perhaps that was probably just an echo of the more strong correlation of if you run more code, whether it's code, your production code, or code in the environment, or code in your test tools, or whatever, the more code you're running, the more flaky it's going to be. And so that really led me to think more about what we're doing in our pipeline to try and reduce those. So I was thinking about our tests, and you could, in some ways you can see this as just like a rephrasing of the test pyramid, but I was thinking about a test and thinking that we want to cover more of the code of our app to give us more confidence. There's a pretty linear relationship between those two things, like this. As the closer we get to covering all of our app, the more confident we are. It's straightforward. But then the same is also true of, according to Google, of the more code that we're executing, the more of our app that we execute, the more code is being executed. It's also a very linear relationship. Except for this bit is not exactly true. It's actually much more of like a stepped sort of relationship like that. So you might have in the bottom left-hand corner some static analysis or things like that, linting and that sort of thing. And right in the top right-hand corner, you've got end-to-end tests running on Selenium or something like that. In between, you've got several points where you're sort of jumping out of the the runtime that you're in or the abstraction you're in. So you might be jumping from your static analysis into the unit test, or from a unit test to the one that's spinning up a JS DOM, or then a real DOM, or and that more and more are jumping up like that. So can you sort of take advantage of the fact that that line has sort of steps in it and the other one doesn't? It's sort of straight. And I think this is the sort of thing that what's his name, Ken C. Dodd, is talking about when he's suggesting that you should focus with the test trophy. You should focus much more on static analysis and integration tests. He's basically saying, get yourself into one of these corners here. So when you're doing an integration test, it's still within JavaScript, you're sort of getting into that point where you're doing as much as you possibly can without stepping out of that JavaScript runtime. And I think that we've found that there's that corner, but there's also other ones at different points throughout the testing chain, and so you can take advantage of those ones, and I'll come back to some examples. And so we're looking at some of this and thinking, okay, but that sort of explains some of it, but it's not really enough. And I can't work out how, if I've got a test that's, maybe I've got a test that's passing 90% of the time, but failing 10% of the time, but it doesn't seem to be that's the case in the pipeline. It feels like it's much worse than that, but I measure it objectively, and it's not. It's like that. And the answer to that comes down to this formula. And does anyone know what that sort of U-shaped N-shaped symbol is? Yeah. So it's the intersection in probability, the intersection between those two probabilities of it happens 90% of the time and 90% of the time. So what's the answer? Yeah. So it's 81%, and often I find probabilities quite sort of counterintuitive. So just having just that sum was enough to make it sort of make sense to me that it's going to go down quite quickly. And it's not the case that if you've got two things that are 90% good, and you put them together, you've got 90% good. It's not. And the problem is that that's true for two tests, but it's also true for many. So if I've got one test that passes 90% of the time, I've got 90%, and then I'm going to go down to 81, 72. And by the time I've got only 5 flaky tests, I've hit almost 50%. I can flip a coin to tell you whether my build pipeline is going to pass. And what makes it worse is these aren't necessarily just tests. It could be any step in our pipeline. So that number is not just the number that you've got in that test suite or in all of your test suites. It's also added to all of the things that you're doing anywhere in your pipeline. And you can see that curve sort of drops off really suddenly at the start before it starts to flatten out. So, okay, you might say, oh, well, 10%, that's pretty bad. So maybe I'd want, I think my tests are less flaky than that. So let's say 1%. So, okay, right. We've got a much flatter line. We're not subject to that quick drop off at the start. But still, by the time you've got to 10 of these events, which they're going to be loads, you've got down to 90%, a pipeline that's going to pass 90% of the time, which still doesn't seem very good. So okay, all right, okay, let's push right down to 0.1%. Okay, now I'm happy with that we've got to 10 and it's still passing 99% of the time. Maybe that's just about good enough. I'll just show that zoomed in as well. So here's the same graph, but just showing the top 2%. Just looks a little bit worse, but we'll come back to that. Basically, what that shows us that even when it's 0.1% chance of it failing, it's still really bad. It's still a problem. So that means that you really, really tiny things that you think very, very rarely occur, they occur one time in 1,000, can still have a really big impact on your pipeline. We tried to do something about that because we might have in the past had something that fails and you think, oh, but it was a one-off. I don't need to do anything about it. It's never going to happen again. It was to do with the environment or something, a solar flare or whatever. And so we decided, okay, well, let's write everything down. Every time anything happens, let's keep a record of it on a wiki. And we did that to try and focus our effort on what we were fixing. But actually, within about a week, we'd found that there were a couple of, I'll get really specific. We had a Jenkins job that would occasionally freeze, and it would freeze on the most innocuous steps, and we couldn't work out what was going on. But the moment we started to record it, it was very clear it happened on the hour. It was a backup issue, and that was as soon as you get into it, it was very easy to fix. But if you're not recording these things, you're never gonna find that. And yeah, and the other thing to say about that is it's very small numbers, but if your application or your pipeline more generally had a real regression rate of 1%, say you were actually introducing regressions at a rate of 1%, and if we plot that on this graph, then suddenly that line which looks not too bad at the start is bad, even that one's bad, because by the time we've gotten to 10 flaky tests, even though they're incredibly unlikely to happen, you still got to the point where when the build fails, it's a 50-50 chance of it being a real regression or something that's actually just a factor of the way your pipeline is working. So it's not a great signal. But luckily, Google were doing a load more research, and Google did some research on their development practices, and there's a report that just lists in minute detail everything that they do at Google. One of the things that sort of jumped out to me was on every project at Google, they just have 3 commands. They have a command for running the tests, a command for doing the build, and a command for running the app. And it's the same command. It doesn't matter what programming language you're using. It doesn't matter who set it up, what product you're working in, whatever. It doesn't matter. It's the same command. And they do that so that it's easy to be able to switch between projects. But it also made me think a bit about the way that we set up our projects. And I was finding that often developers were getting into a situation where they said, "Oh, I've done my bit. I ran the tests. I did everything on my machine, and then I deployed it, and some tests failed." And generally, it was because they were running the tests, but they were running them slightly in the wrong way, or they weren't running as many things as were actually going to happen on the continuous delivery, continuous integration pipeline. And so we just decided to just standardize and just went through all of our products, all of our every single repository, and make sure that it has a command that is test CI that, regardless of where you are, will just do the same thing as what's going to happen on the continuous integration environment. So it'll make sure that the right feature toggles are on, it'll do things with the concurrency, it'll make sure coverage is, whatever. You don't need to think about it, you just run this thing. If that thing passes, you're okay, you've done your job. There's no relying on an environment variable or anything like that. That made a big difference, but we were still that meant that we were getting fewer fails that were actually legitimate fails that hadn't have been caught earlier on, but we were still getting a lot of these failures that were more to do with flakiness of the build or the tests or whatever. And so we went back to trying to focus to being in that sort of blue square on the staircase. We did a number of things, like we pulled out parts of the application and ran just those in Selenium, but ignoring any HTTP calls. And we also did things, this is another really specific example, but we have in one of the apps that we look after, we have a sort of toolbar that becomes sticky when you scroll down. You probably all got it. But just that very specific feature, lovely though it was for the journalists who were using it, was really, really causing havoc with our end-to-end tests. And so we did this. I'm going to show you. Yeah, I'm not proud of it. There are a lot of problems with this. We've got we're doing important. We've got code in strings. We've got all sorts of things wrong with this. It's not an example of clean code, but what it is an example of being pragmatic with our pipeline and just cutting off a corner of some of the complexity so that we can focus on getting as much confidence as we can without having to create a load of noise in our pipelines of false failures. So you can see we're just taking a bit of CSS and injecting in and telling Selenium to do that. That went really well, and we thought, oh, this is fantastic. All we need to do is just read some reports by Google or read the book and then do what they say and everything's fine, and we'll just do that. So the next thing we tried was to make sure that just can follow completely by the book. If there's a broken build, that commit was bad. We need to revert that commit, roll back the deploy, and just everything's clean for the next person. That's what you should do. Also, it's great, it's going to align incentives. It'll mean that developers really won't want to break the build because it'll waste a load of their time if they do that. The problem is it wastes a load of their time if they do that. And so I'm not going to say carnage, but we tried it, and within a week we'd gone back to allowing developers to manage it responsibly themselves, and giving them some tools to do that so that they can easily revert it or enroll it back, but not making that decision automatically, because we just found we couldn't keep track of what was being deployed to an environment at a given time. And it was, if you go back to the point of the continuous integration, to being to automate things and save us time, it was just generating tasks that were wasting our time. So we rolled that back. That's not to say that we've given up on trying to follow the book. We are still doing some things, trying to do some things like that. The one that's circulating in the team at the moment is this book, the DevOps Handbook. And I don't know, before I read this, my definition of DevOps would have been, well, it used to be called sysadmin and now they do some code, so they've just changed the name to DevOps. And maybe that is some definition, but that's certainly not the definition that they're using in this book. In the book, they're using it more to describe taking the sort of techniques that you use for managing your app and applying that more generally to other contexts. So to, for example, your delivery pipeline. And one of the big things that they go on about a lot is you wouldn't deploy an app without having some metrics about how it's performing and performance. So you really shouldn't have a pipeline that it isn't gathering some metrics about how it's performing, because otherwise you don't even know how well you're doing. So this is an example of one of the things that we did. This is a Cucumber hook that's just making sure that afterwards we get the test result and the scenario result and just send that off to statsd. And I'm showing this not because it's particularly Cucumber specific. Actually, all of the test frameworks, whether it's Jest or Ava or Tap or whatever you're looking at, they all have an API like this for you to be able to hook into the test results and send it off, gathering this sort of metrics. And it's really, really useful. And we now do this just all over, and also within our Jenkins pipelines, just statsd on everything. You just throw it in there and you don't need to think about it until you need to look at the graphs. I think this is the last thing I'm going to show you. That the other thing that they go on about in the DevOps Handbook is about just doing as much automation as you can of the pipeline as well. And so the message that I showed you at the start in our CI builds channel has now evolved to look a bit more like this. So we send, if a build does fail, we send a direct message to the person who triggered the build. And my favorite thing about this is it sums up quite a few different things in one little message that is telling you what's happening, but also that second line, once you've investigated the issue, so it's making very clear what the expectation is. We sent you a direct message, you've got a task, go and do something, which for junior developers who might not necessarily have such a, it's not sort of ingrained into them that it's now their top priority. It's very clear that they just need to follow that. And then the third thing is just asking them to provide a little bit of feedback. So once they've investigated, they click on one of these buttons and again it goes off to statsd to record exactly what it is, so we can find out, is it that there's a regression or is it a test failure, and if it's one of our existing known issues, which one, so we know exactly when they're happening and how frequently they're happening, so we can know which are the broken windows that we need to prioritize fixing. And so automating that has been a huge help in making sure that everyone does that, and we always know what was the root cause. So now everything's good. We've fixed everything, and it's always green. Except for obviously it's not. Obviously we're still fighting that battle, but I think now at least we know a little bit more about what our problems are, and we're able to measure a little bit, so that hopefully when we do end up in that retro where suddenly everyone says, I can't do anything because the pipeline's blocked all the time, we can see it coming and we know what to do about it when it does happen. And I'm just going to pull out 3 themes that I think have sort of gone through all of this. And the first one is just on focusing on the developers as users. Particularly if you're a more senior developer, there is nothing you can do that will endear you to the team more than just doing something that will help them in their day job and just improve a command a little bit. Just do something that just makes something a little bit quicker. They love it, and often it will help you on whatever you're trying to do as well. And then obviously we always just push everything as much as you can further down the pipeline. So when you're cutting off those little bits of complexity on that staircase, often it means that you can run things earlier on as well, and that's a massive help in keeping the pipeline green. And the third one is, just absolutely measure everything. StatsD is amazing. Just throw data in there. Just get whatever you can, because it will be useful, and you don't know why, but it will be when it comes up. You'll know then. And I think the last thing to leave you with is just to say we're hiring, and I'm going to talk for a while so that those links are on the screen and for enough time for people to be able to read them. And I was talking to Richard just before I did this, and to sort of check, is it okay to just put a slide up saying this? And he said, yeah, but only if you explain exactly what the team does. So I will. We're the content production workflows team, and we do a load of work for journalists. We provide it's the platform for any sort of content creator in the BBC to get content onto the BBC News website, BBC News app. It used to be also for teletext, Red Button, basically you name it, it all goes through this platform. And we're currently working on developing a new article editor for the news website, but also doing a load of work with adding more metadata onto content so that we can target people much more based on what the sorts of things they're interested in, rather than just saying, you listen to this song, you probably like another song like that. More sort of moods and things like that. And I think that's it.
Do you do any pre-commit, pre-merge testing? So why does your build ever go on green if you're testing everything before you commit?
Well, do you mean from a test perspective? One would be that some tests, we don't spin up a new environment on a branch. So often we'll have really big apps that talk with lots of different systems in the BBC. So we can only do our full end-to-end tests when it's actually deployed. There we go.